Good morning, children. Here I am your teacher. Yes, children, in the last class you got some knowledge about the origin of geometry and how people in ancient civilization were scholar in geometry. In today's class we are going to know how Greeks were given contribution to geometry. Yes, children, in the last class you had learned that in ancient time geometry was being developed and it applied everywhere in the world, but this was happening in an unsystematic manner, and they passed their messages from generation to generation by orally or through palm leaf messages. And also the peoples in Egyptian and Babylonia civilization, they used geometry only for practical purposes, and they interested only on the result of the statement. Yes, only they used only the techniques behind that statement. Yes, children. Okay, let me explain clearly. You know that this is a circle. When a diameter is drawn between the 2 points on the circumference of the circle, it cuts the circle into 2 equal halves, isn't it? This is one statement. So, the peoples of Egyptian, they interested only on that result. So, what is the result of this statement? Yes, getting the 2 equal halves of the circle is the result of the statement. So, the people only interested on that result. Whenever they came across a situation like they want to cut the circular object into 2 equal halves, so they simply use the technique to, as they are going to draw a diameter and cuts the circular object. This is only the technique they used, and they used it crudely, and they not interested why it happens and how it happens and what is the logic behind this. They did not interested in that. Maybe the scholars knew this, but they failed to pass the knowledge to common people, because there is no book written by people in Egyptian, Babylonia, Rome, Indus Valley civilization like that. But Greeks, they gave importance how certain constructions in geometry works. Yes. And what will be the reason behind this? The Greeks were interested in establishing the truth of the statements they discovered using the deductive reasoning. In the picture, it represents how Greeks were interested in establishing the proofs of the statements by deductive reasoning. Yes, children, what do you mean by this deductive reasoning? Okay, let me explain now. Here, one sentence is there. What is the color of your hair? Is it a statement? No. Is it not a statement? Because this is a question, isn't it? Again, please go and bring me some water. Is this a statement? No, this is also not a statement, because this is a request. This is a request, isn't it? So, what do you mean by the statement? Can you give example to a statement? Yes, the color of your hair is black. This is a statement. No? So, statements may be true or may be false, isn't it? Statements are always true, are always false, or ambiguous. So, what do you mean by this ambiguous? Here one statement is there. Dogs are intelligent. You agree that this is a statement, isn't it? Dogs are intelligent. But in this sentence, for some people believe this is true, isn't it? But others do not. So, these type of sentences we called it as ambiguous statements. I hope you understood now. But in mathematics, the statement should not be ambiguous. In mathematics, the statement should not be ambiguous. You know that 5 plus 2 is equal to 7. This is always true. Or otherwise, 5 plus 3 is equal to 7. This is always false. So in mathematics, there are only unambiguous statements are there. So, the main logical tool used in establishing the truth of an unambiguous statement. An ambiguous statement means the statements having only one meaning and leading to only one conclusion we called it as a deductive reasoning, and the Greeks were interested in deductive reasoning for proving any statements. Yes, children. A Greek mathematician Thales credited with giving the first known proof. That is, this proof was of the statement that a circle is bisected, that it cut into two equal parts by its diameter. Then later Euclid's, one of the famous pupil of Euclid, that is, he is, yes, Pythagoras. Yes, children, whom you have heard about. Pythagoras and his group discovered many geometric properties and developed the theory of geometry to a great extent. Then later Euclid, he was a teacher of mathematics, and at Alexandria in Egypt. He collected all the known work and arranged it in his famous book called Elements. He divided the elements into 13 chapters, each called a book. These books influenced the whole world's understanding of geometry for next upcoming generations. So Euclid was known as father of geometry. Children, in this chapter we shall discuss Euclid's approach to geometry and shall try to link it with the present day geometry. The Greek mathematicians of Euclid's time thought of geometry as an abstract model of the world in which they lived. Yes, children. They derived point, line and surface from what they seen around them, like house, tree, mountain, etc. You know, children, a solid has a shape, size, position and can be moved from one place to another, and its boundaries are called surfaces. Here, in this picture, this is a pyramid. Its boundaries are called surfaces. The boundaries of surfaces are curve or straight lines. Here in this example, the boundaries of the surfaces are straight lines. These lines ends at a point here. In 1, 2, 3, 4, 5. These are the points. Now children, consider the three steps from solids to points. First solid, then surface, then lines and then points. Observe carefully. In each step we lost one dimension, isn't it? Here is a solid, isn't it? It has three dimensions, that is length, breadth and height. And again, this is a surface of a square based pyramid here. It has only two dimensions, that is length and breadth. Okay, in the next step, that is a line. Observe carefully. In this, a line has only one dimension, that is length. Next, points. Yes, point has no dimension. I will going to summarize this. Solid, first we come across solid, that it has length, breadth and height. Next plane, it has only two dimensions, that is length and breadth. Next line, it has only one dimension, that is length, and then point, none. Euclid summarized these statements as definitions. He began his exposition by listing 23 definitions in book 1 of the elements. Children, we will learn few of them now. Okay, children, what is this? Yes, this is a point. According to Euclid, point is that which has no part. Point is that which has no part. Okay, this is his first definition about point. In the next, he defined, yes, this is a line. He defined line. Line is breadthless length. Yes, line is a breadthless because line has no thickness, isn't it? So it is a breadthless length. In his third definition, he derived points. Yes, here you are observing 2 points at the end of a line AB. The points are A and B. So he called the ends of a line are points. Okay, in the next definition, Euclid define a straight line. Let me draw a straight line through points here. I am going to take some points here like A, B, C, D, E, like this. Can I join these points through a line segment? Yes, I can. I can join these points through a line segments like this, isn't it, children? So, we can say a straight line is a line which lies evenly with the points on itself. A straight line is a line which lies evenly with the points on itself. So, this is what the fourth definition of the Euclid. What is the fourth definition of the Euclid? A straight line is a line which lies evenly with the points on itself. I hope you understood, children. Shall we move to the next definition? Yes, surface. A surface is that which has length and breadth only. Here solid surface of a pyramid is there, isn't it? It has 1, 2, 3, 4, 5, 6 surfaces, and surfaces are in the shape of a triangle and pentagon. So surface is that which has length and breadth only. In the next definition, here again define line. Here you are observing so many solids. Observe carefully the edges of a surfaces. The edges of a surfaces are lines, isn't it? Either a curved lines or a straight line. So he called line as the edges of a surface. Okay. Shall we move to his last definition, that is a plane surface. Here you are observing a plane surfaces. These plane surfaces which lies evenly with the straight line on itself. So this is the last definition of the Euclid. I am going to summarize this. In the first definition, here it contains a part, isn't it? It needs to be defined. Suppose we define a part to be that which occupies area. If I define part as a occupies area, again an area needs to be defined, isn't it? So to define one thing, you need to define many other things, and you may get a long chain of definitions without an end. For such reason, mathematicians agree to leave some geometrical terms undefined. So, in mathematics, the undefined terms are a point, a line, and a plane. So, remember, children, in mathematics, according to Euclid, in mathematics, the undefined terms are point, line, and a plane. The only thing is that we can explain them with the help of physical models. If we take any physical models like solid, pyramid, like that, we can explain a point, a line, a plane by using that physical models. This is about the definitions of the Euclids. In the next class, we can learn the assumptions of the Euclids, assumed properties of the Euclids. Okay, children, I hope you understood. Thank you.